Today we are exploring a fascinating breakthrough in aviation safety, an invention that has emerged from the minds of two students in Dubai and is now attracting worldwide attention. It is called Project REBIRTH. And it represents a bold attempt to tackle one of the most frightening challenges in air travel, the possibility of a catastrophic crash. Developed by Eshel, Wasim, and Dharsan Srinivasan from the Birla Institute of Technology and Science in Dubai. This project is built on the idea of using artificial intelligence to intervene in a moment where human control and traditional safety mechanisms can no longer prevent disaster. The core idea is deceptively simple but deeply innovative. Wrap the aircraft in massive external airbags that deploy when an imminent crash is detected, cushioning the impact and increasing the survival chances of passengers on board. To understand why this matters so much, we need to recognize the context in which the project was born. In June of 2025, the aviation world was shaken by the Air India Flight 171 tragedy. An accident that claimed many lives and once again highlighted how vulnerable even modern aircraft can be in extreme scenarios. For Wasim and Srinivasan, this tragedy was more than just a news headline. It became the spark that drove them to think differently about what could be done. Commercial aviation has historically focused on reducing the likelihood of accidents through redundant systems, advanced pilot training, and rigorous maintenance standards. But when a crash becomes unavoidable, when every layer of defense has been stripped away, survival chances are usually slim. That gap, that moment of no return, is exactly where Project REBIRTH steps in. The technical heart of the system lies in its artificial intelligence engine. Rather than relying only on manual control or delayed reactions, the AI constantly monitors flight data in real time. It looks at variables such as altitude, airspeed, engine performance, flight path, and environmental conditions. If it determines that a crash is imminent and cannot be averted by normal corrective actions, it triggers the deployment of the safety system. This is important because the timeline in an accident scenario can be brutally short. Humans, even highly trained pilots, may not have the luxury of time to respond effectively. AI, on the other hand, can calculate probabilities, detect anomalies, and make life-saving decisions in fractions of a second. Once the AI reaches the decision point, Project REBIRTH deploys its most striking feature: a network of massive, high-strength airbags that envelop the aircraft from the outside. These are not the small airbags we see in cars. They are industrial scale, engineered to withstand enormous forces. Imagine an aircraft suddenly being cocooned in layers of protective cushioning as it makes contact with the ground or water. The design aims to absorb the kinetic energy of the impact, reduce structural breakup, and give those inside the cabin a significantly greater chance of surviving. While this may sound like science fiction, the concept has parallels in other industries. We already see impact-absorbing technologies in automotive engineering, space capsule landings, and even in military applications. What makes Project REBIRTH unique is how it adapts these principles to the highly complex world of commercial aviation. From a performance standpoint, there are several interesting elements to discuss. First is the speed of deployment. Airbags on a car inflate in milliseconds. And for aircraft, this window has to be similarly rapid, but scaled up dramatically. The system needs to envelop large portions of a fuselage almost instantly, which means materials, gas generators, and trigger mechanisms have to work in flawless sync. Second is durability. At the scale of a passenger jet, the airbags cannot simply burst or tear upon impact. They must be designed from advanced polymers or reinforced fabrics that combine flexibility with extreme toughness. Third is the integration with the aircraft's existing systems. Deploying external airbags at the wrong moment could itself be catastrophic. So the AI logic must be watertight in ensuring that deployment occurs only when absolutely necessary and not in situations where normal flight operations can continue. A natural question people might have is about aerodynamics and storage. Where would these massive airbags be stored when not in use? And how would they avoid interfering with the aircraft's performance during normal flight? The design addresses this by concealing the airbags in streamlined compartments along the fuselage and wings, places where they add minimal drag and weight. The compartments are engineered to blend with the aircraft body, maintaining aerodynamic efficiency. In other words, a passenger flying on a plane equipped with Project Rebirth would not see bulky attachments or strange appendages. The system remains invisible and unobtrusive until the exact moment it is needed. Another point worth noting is scalability. The students designed Project Rebirth with commercial airliners in mind, but the technology can, in principle, be adapted for different classes of aircraft, from small private planes to large cargo jets. Each application would require adjustments in scale, deployment logic, and material choice, but the fundamental principle remains the same. Use AI to detect the unavoidable, and use physical cushioning to soften the blow. For industries like cargo aviation, where loss of life may not be the primary concern, but protecting valuable goods still matters. This system could also provide a new layer of security. Beyond the technical elements, what makes this project stand out is the boldness of the vision. Aviation safety has often been about incremental improvements. Slightly better engines, slightly more efficient radar, slightly stronger. Project Rebirth represents a leap into a new category of safety intervention. It imagines an aircraft not as an immovable object hurtling toward destruction, but as something that can transform in its final moments to protect those on board. That psychological shift from helplessness to a last layer of defense is something that resonates not just with engineers and experts, but also with ordinary passengers who often fear what would happen in a worst-case scenario. The fact that this innovation comes from students is equally significant. Wasim and Srinivasan are not yet part of a massive aerospace company with billions in research funding. They are learners who combined technical curiosity with compassion, taking inspiration from tragedy and transforming it into a solution. This speaks volumes about the democratization of innovation with the right tools and mindset. Even young students can create ideas that challenge industry norms and potentially save lives. Their submission of Project Rebirth for the James Dyson Award further underscores its importance. This is not just a student assignment or a thought experiment. It is being evaluated on an international stage where design, engineering, and real-world impact are taken very seriously. Experts in the field are beginning to take notice, and the early feedback has been cautiously optimistic. Of course, there are practical hurdles to overcome. Questions about weight, maintenance, costs, and regulatory approval will need detailed answers. But the consensus seems to be that the concept is not only intriguing, but also potentially transformative. One aviation analyst described it as a promising step towards safer aviation, a phrase that captures both the excitement and the realism of what lies ahead. No one is claiming that airbags will suddenly make every crash survivable. The forces involved in certain accidents, such as mid-air collisions or high-speed impacts, may exceed what any cushioning system can handle. Yet, for a range of scenarios, especially controlled crash landings, hard touchdowns, or runway overruns, the system could dramatically tilt the odds in favor of survival. Let us also take a closer look at the human factor. Passengers today are reassured by seatbelts, oxygen masks, life vests, and a crew trained in emergency procedures. These are important but limited measures. Project Rebirth adds an entirely new dimension to the passenger's safety net, one that operates outside the cabin and on a much larger scale. For many travelers, simply knowing that such a system exists could reduce anxiety about flying. Airlines, always attentive to passenger confidence, may see this as a marketing advantage in addition to a safety feature. Imagine booking a ticket and noticing that the aircraft is equipped with next-generation AI airbags designed to maximize survival chances. That detail could sway consumer choice in competitive markets. From an engineering design perspective, the system embodies elegance and complexity. On one hand, it is immensely sophisticated, involving advanced AI algorithms, complex deployment mechanisms, and cutting-edge materials science. On the other hand, its purpose can be explained in a single sentence understandable to anyone. When a crash is unavoidable, the plane wraps itself in airbags to protect you. That clarity of purpose is a powerful element of design thinking. Many groundbreaking innovations succeed, not because they are the most technically advanced, but because they solve a problem in a way that is both effective and easily communicated. When we imagine the potential real-world deployment of Project Rebirth, several scenarios come to mind. In the case of a failed landing attempt where the aircraft is descending too steeply and cannot stop on the runway, airbags could absorb the impact and keep the fuselage intact. In a situation where an aircraft must ditch into the ocean, external airbags could not only soften the landing, but also aid in buoyancy, keeping the aircraft afloat longer and making evacuation safer. In mountainous regions, where crashes into rugged terrain can be especially deadly, a cocooning system could reduce the severity of impact forces. These are not guarantees of perfect safety, but they are meaningful improvements that could translate into lives saved. It is also worth discussing the future possibilities that build upon this foundation. If Project Rebirth proves feasible, it could inspire additional layers of innovation. For example, combining external airbags with deployable parachute systems for smaller aircraft, or integrating with drone technology to assist in post-crash rescue operations. The AI component could also expand beyond crash detection into other predictive safety measures, such as anticipating mechanical failures before they escalate into emergencies. In this sense, Project Rebirth may be seen not just as a standalone invention, but as a stepping stone toward a broader reimagining of aviation safety. The name itself, Project Rebirth, carries symbolic weight. Rebirth suggests a second chance, survival against the odds, and a renewal of hope, even in dire circumstances. For passengers and families who have lived through the trauma of aviation disasters, the very notion that technology might offer that second chance is profoundly meaningful. It transforms the narrative of air accidents from inevitability to possibility, from fatalism to resilience. As with any new invention, skepticism will play an important role. Engineers, regulators, and airlines will demand rigorous testing, simulations, and certifications. Weight is a particularly sensitive issue in aviation, where every kilogram matters for fuel efficiency and operational costs. Maintenance teams will need to evaluate how often the system must be checked, whether components degrade over time, and how quickly they can be replaced after deployment. There will also be cost considerations. Equipping an aircraft with such a system could add millions to its price tag. Airlines will have to balance that against the potential value of lives saved, the reduction of liability, and the marketing appeal of offering enhanced safety. Public acceptance will evolve as well. Just as passengers once had to get used to the idea of seatbelts or reinforced cockpit doors, they will have to learn what it means for their plane to carry external air. Education campaigns, safety demonstrations, and transparent communication will be critical in building trust. Over time, what seems unusual today could become a standard feature tomorrow, much like airbags in cars, which were once dismissed as unnecessary and are now considered essential. Ultimately, what Project Rebirth brings to the table is not only a practical invention, but also a cultural shift in how we think about safety. It challenges the assumption that once a plane is in a crash trajectory, nothing more can be done. It says that even in that moment, technology can intervene to give passengers a fighting chance. That shift in perspective may prove to be its greatest legacy, regardless of how quickly or widely the system is adopted.